Welcome to the Contributing to Yetibot Workshop. So Yetibot has a lot of functionality, most of which we won't cover today. Here's a quick whirlwind tour of some of the stuff it can do. So a little bit about Yetibot. I started Yetibot in 2011 as an excuse to learn Clojure, which is a Lisp. Oh, I should put this on. And continued developing it ever since, as you can see from this not too sparse commit chart. It's an open source project licensed under EPL, the same as Clojure. I've got about 2,800 commits from 22 contributors, a little over 10,000 lines of Clojure, 4 core team members across 3 countries. And most recently, I got it approved as an official eBay external open source project, which means that eBay employees are able to contribute to it as long as all the commits are reviewed by me and we make sure that we're not leaking any kind of secrets or anything like that. So Clojure runs on the JVM. It's got great Java interop. I'm running it on Docker on our tests IO cluster. So if you see Yetibot in Slack, that's where it's running. So currently, some of the more productivity things that Yetibot does are talking to our Jira, our GitHub, and our Jenkins. So for instance, you can ask for help on GitHub and see that it does all these things. So if I wanted to get all the open PRs for a given organization, like Node.js, we could ask it to show us open PRs. On the Jira side, just the project.
You are the first person to join the conference.
You can query Jira recent issues, you can comment on issues, and so on. So I want to kind of position Yetibot as eBay's automation front end. When I first started it, it was all about fun, like how to generate memes and GIFs and do fun stuff like that. It kind of quickly became a part of our team's culture, hanging out in Slack every morning, like looking up the weather, cams for the cities that we live in, looking up stock prices, stuff like that. But it's also a useful tool for productivity-oriented stuff. So like I said, we currently have a few things, but this is just the beginning, and I'm planning to add a lot more soon. So here's the agenda for today. We'll go over some Yetibot fundamentals. These are kind of the underlying behaviors that power Yetibot and allow, for example, commands to be composed together and used in unanticipated ways, so that if you create a command, some kind of integration for Yetibot, these underlying ways that Yetibot allows you to compose commands and alias commands and run them on timers and stuff like that kind of powers up the integration that you wrote. Next, we'll live code a Yetibot feature. So we're going to extend the existing weather command by adding forecast support. So currently, if we run help on weather, we can see that it just has pretty bare bones weather for location support. Then I'll provide some resources for getting started with Clojure and setting up your environment, and we'll have some open time for questions playing with Clojure and hacking on Yetibot. So if you'd like, you can join Yetibot Workshop Slack channel to follow along and inject chaos into the presentation if you'd like. So Yetibot fundamentals. We're going to look at an alias that will help us cover all these topics. So aliases, that's just a way to give a name to an expression similar to bash aliases. Expression composition via pipes. This is also inspired by the shell. So you can compose multiple commands left to right. We'll go over the 2 types of responses from Yetibot, which are individual values and lists of values. We'll look at Xargs, which is a way to run a command for every item in a list. And then we'll look at the data and render support, which allows you to custom render output from a command using the data that was like fetched from an API for that command. That'll make sense in a few minutes. So alltemps. We can ask Yetibot help for alltemps, and we can see that it's an alias for this expression. So if we run alltemps, we can get a list of multiple temperatures for all these locations, and that's the same as running this. So let's deconstruct that a little bit. We can ask for help on locks, and we see that's an alias for a list of zip codes. Xargs, like I said, that works kind of like Bash's Xargs, where you can run a command for every item in a list. So a really easy example would be to take our locks list and then use Xargs with echo to prepend a message before each item. And then loctemp is a little bit more complicated. So what that's doing is calling weather for every item, or for an argument, and this is the syntax for arguments, and then we pipe that to render. And so what's actually going on, if we run weather for a zip code, we can see we get this kind of multi-line output. But when we run weather for multiple locations, we want a more concise, consolidated output, and that's where render comes in. When this calls the API for a given location, we're getting a ton of data back from that API, but then we kind of we give up some of that data by deriving this more human-friendly string. So what Yetibot does is it actually propagates data behind pipes, and we can actually look at the raw data by saying data show. And we see a map. This is a Clojure map representing the API response. So there's a lot more stuff available here than what we had in the string up here. If we ask again for that alias on loctemp, we can see we're rendering, and this is a templating language here that has support for things like multiplication, adding, string uppercase, tons of stuff like that, title case. So we're grabbing the temp, which is returned in Celsius, piping that over to multiply, add, and round to convert it to Fahrenheit. We're grabbing the relative humidity. This is the syntax for grabbing a nested key out of our weather dot description map, city name, and state code. So I can run that directly, passing a location to it.
Were you able to get sound working?
I'm not sure if VMR is working.
Someone dialed in to see if it's showing up. It's not showing up.
All right, so we'll continue. Sorry, one second, I keep losing my remote. So again, that's the example of loctemp, giving it a location, and give it any zip code or city name, and we get the custom rendering using that templating language. Last item is sort, and that does what you'd expect. So it sorts numerically or alphabetically, depending on what you give it. We could sort our list of locations like that. So backing up, alltemps, we went over that. We saw it's an alias for this expression, and then loctemp was an alias for this expression. So aliases can... Are you in a channel that Yetibot's in?
Also, the channel has to be configured so that it uses...
You can type /invite and then @Yetibot, and Yetibot will join, and then it'll work.
I was just trying on my private talking to myself.
Oh yeah, it won't work there because you'd have to create a channel, because if you're just in a personal DM, Yetibot can't join that. You can also DM Yetibot directly. So if you hit like Command K, type @Yetibot, you can talk to it directly. Yeah, so either create a channel or private message. So that is the way Yetibot works, kind of the fundamental features that power composition, naming existing expressions. And so using these, we get a lot of power. Like I said, when you add a feature, there's a lot more to it than just that feature that you're gaining because of the way that commands can be composed together. Any questions on that? Anything else you want to see?
So Yetibot is running on a server on its own, and it is kind of a HTTP server that responds to these APIs.
Yeah, it listens to a streaming connection from Slack's API.
Okay.
So yeah, it uses a socket and gets different events based on if people join rooms, private message, group message, react. Like if you put an emoji reaction on a message, like Yetibot can react to that.
Okay.
So yeah, Slack API.
So exclamation is the one that invokes Yetibot?
Right. That's just the configured prefix, and that's actually configurable. So you could set it to any symbol you want. That's just so that not every message is triggering Yetibot, right? Because Yetibot's like in our general channel and our random channel. So I wanted to be explicit about triggering commands. Anything else you want to see? Uh-huh. Yeah, so say /invite at Yetibot, and it should join.
I didn't understand what happened there. Chuck scene gates, you repeated 2 times, so
Yeah.
what exactly is the message that is coming?
So repeat is a command. You can ask for help on repeat. And so repeat, you say n times and then the command. So if I said repeat 5, echo hi or hello, we get 5 hellos.
Yes, but the message, the scene gates can spawn 2 threads. So where,
So that's the Chuck command, which is Chuck Norris. You can just, oops. You can type Chuck. Or you can give it a custom name, and it'll create like a Chuck Norris joke using the name that you give it. So lots of fun stuff like that. And then you could take that message and like type it to a meme like this, or to a Yetibot meme. So there's lots of fun, weird ways to compose commands together. The next section, we're going to live code a new feature. Before we go to that, any other questions on fundamentals or usage? Okay. So like I said, we're going to look at the weather command, and I'll go over a little bit of Clojure basics too, since it's a little different than like JavaScript or other normal languages. Okay, so in my editor, I can evaluate any of these expressions. So these are literals for the simple types you'd expect in any language. And you can see the value on the bottom in the status line, or I can print that over on the right side. So numbers, strings, this is called a vector. It's just a simple collection type. Clojure uses prefix operators, so instead of like JavaScript or Java 5+5 or X plus Y or whatever, you put the operator at the beginning. One benefit of that is you can send as many arguments to it as you want, and it'll sum all of those. If expressions, so if condition, then it returns the first expression, otherwise the second. And then printing lines, pretty basic stuff. So this shows you what a nested expression looks like. They can be nested as deep as you want. And one kind of interesting property of Lisp is that we're basically writing code in an abstract syntax tree format. So there's no translation between the syntax and kind of the representation that would normally happen in the compiler. So variables, we can just say def, give it a name and a value. It could be any value. Once it's defined, we can then evaluate that, and it will always return 42. Regular expressions, this is the regex, and this is the string to match, and we can see it parses out the pieces. That means non-white space, followed by white space, followed by any number of digits in the end. So these are some common data structures. They can contain any sort of items. So we can see here we have a number. This is a keyword. This is a string. This is a map, which in Clojure is super common. So it's a very data-heavy language. There's lots of really deeply nested data structures, and Clojure has a ton of great functions for kind of like looking into those data structures, manipulating them, filtering them, and so on. So these are the kind of top constructors for those various data structures. We can pass any arguments to a list, and it'll create a list structure for us. Same with vector, hash map, hash set, and so on. So let's look at a little more realistic example. We have a user map that represents some user. So I can print that. If I want to pull keys out of it, this is the syntax. There's a few different ways of doing that. You can use the username keyword and pass a map to it. And this is acting like a function. So in Clojure, the first item inside of an S expression, which is what we're looking at, surrounded by parentheses, is the function to execute, and then all other items in the list are arguments to that function. So we can say user name from user, or we can put it the other way around, and that's because in Clojure, maps act like functions. So we're calling the user function, or the user map, as if it was a function, passing the username argument to it, and we get the same result. And then there's a third way to do the same thing, which is reaching into a map with get, and then passing the key to get from it. If we pass a key that doesn't exist, we simply get nil. And then one other feature that get has that the other ways don't is you can provide a default value if that key doesn't exist in the map. So we get default value. We can add new items to a map with associate. And one important thing to note is that we're not mutating the original data structure. So if we wanted to kind of like get a reference to this, we'd have to define a new variable. So if I go back and evaluate user, we can see that it was unchanged, where new user has this new GitHub key. You can also remove items, and again, it's immutable, so it's not mutating the original thing. So that's a quick whirlwind tour of some of the basic Clojure language features. It's very data heavy, like I said, and you can see the workflow is super interactive. So as we're building new features, we're constantly evaluating functions as we define them, executing them. Another common way would be to write tests and run the tests in the REPL instead of like having an automatic test runner or something like that. So if we look at the existing functionality, earlier I showed the help string for weather, and that entry point is right here. So command hook is a way that you register a new command in Yetibot. The first argument is always regex that maps to the way you invoke a command. So in this case it's weather, and then under that are all the sub-expressions. So right now we have two weather commands. One is you pass it anything, and it tries to find the location for whatever you passed it. And the second option is you pass it nothing, and then it finds the weather for the default configured location. So the default location is Seattle. Looks like people have been playing with the channel. So let's try to add forecast functionality. We'll start by looking at this function called current. I can ask for a little bit of help on that function by calling doc on it. There's no doc string, so it just says not documented, but we can at least see the arguments, which is location. If I run that for this argument, San Jose, we get a response from the API, and I can print that over here in my REPL output. So we can see again we have all this data that came back from the API. So let's look at the current function, and we can see it's calling get by location, passing current and the location. If we look at get by location, we can see that's just doing some postal code parsing, and it either tries to do a lookup using a postal and country code or the city name that you gave it. So since we're using forecast, we'll want to have that same kind of functionality to parse postal codes or city names. I'll pull up the docs really quick for weather. So these are the docs for the current weather API that we're calling, which is just /current. These are all the various API endpoints that you could call. And here's the 16-day weather forecast API, which is what we want. So that's /forecast/daily. Let's try that out. So I can evaluate this entire namespace, and all these functions are reevaluated, reloaded into the REPL. And now I can go back down to my comment block, and we'll try it out. So forecast. And we can see we got a response back from the API. We can print that again. And we can see some of the top level keys on the map include city name, country code, state code, and so on. If we look at the other side of the map, we can see it has this data key, and inside that it's a collection or a vector of maps. And each one of those contains a forecast for a given day. Valid date. So if we look quickly through a bunch of these valid dates, we can see it just increases. The 26th, 27th, 28th looks good. And then we can see some other keys that we're interested in, like temperature. So we'll look at outputting max temp and min temp for each day. So if we go back down to command hook, we can kind of stub out some of the basic functionality that we want for the forecast command. First of all, we define the sub command that we want to execute, followed by any arguments. So forecast, any number of white space, and then we want anything you give it, whether it's digits for postal code or strings for city code or city and state. So the left side is the pattern that you want to match from user input, and the right side is the command that you want to execute. If we look at weather command, defined here, this is kind of the basic pattern of what we want to do. First of all, it provides a doc string, and that's what powers when you say help command in Yetibot. It looks up this metadata that's associated with a variable on the command. This is the argument list, and this illustrates some destructuring. So there's a bunch of keys that are passed to every command in Yetibot, including like user, the channel that you're in, anything that was piped to it, the data that was piped to it, and any arguments. For weather, it's pretty simple. We just want to look at the argument that was passed. And so that's what this is doing here. It's destructuring a match key from the map. Then it calls the API. It does some error handling. So if there's an error from the response, it'll return that. If there's no error, this function will return nil, and instead it'll return a valid result. So let's grab this and kind of model our forecast function after it. Got the current, got the forecast for location. So we need to change this to forecast. But first, let's just do kind of a sanity check. I'll put this here and return match, just to see that we're pulling out the right arguments and capturing them correctly. So if I reload this, I'm going to switch over to Workshop Dev. And I'm going to start my local Yetibot so that we can actually interact with it in Slack. Oops, I think I just messed that up. So this is starting up my Yetibot on this machine, connecting to the Slack API. And then as we reevaluate commands in Vim, it's actually modifying our running Yetibot, and we can play with it as we develop it. Okay. So back in Slack, Yetibot should be up. There it is, Yetibot dev eng. We can ask it for help on weather, and we can see that the new command we added, weather forecast location, is now part of the doc string. We can execute that and see that it's just returning the regex map or match. So what we need to do is destructure match, because currently it's a collection. It includes the entire string plus the matched portion from that capture group in the regex. So all we care about is that matched portion. So I can change my destructuring. What this is doing is it's pulling out the match. This is exactly what we did before, but it's a different syntax. Pulling out the match key from the map passed to this function and assigning it to a variable called match. But again, match was a collection, and we only wanted the second item in that collection, which corresponds to that Seattle string. So we can destructure it even deeper by basically discarding the first variable and only capturing the second. So if I reevaluate that, go back over to Slack, try it again, now we should only see Seattle. We can also test it out on zip codes. Cool, so that looks good. Now let's switch back to what we were doing before, getting the API result, doing some error handling, and then processing that result. So a let expression just gives a name. It's kind of like defining a variable, but the important part is that this variable result only exists within the scope. You can visually see it with the indentation. Result is only, like if you called it outside of that, it wouldn't exist. So we're calling forecast match, and that should give us this kind of data structure, which means we could start pulling out parts of the map, like city name and country code. So let's look at what that would look like. This block here is another let where we're destructuring the result even further after making sure there wasn't an error. So for now, let's just test pulling out city name. So I can change this destructuring syntax and say keys city name, and then we'll return that as the value. So earlier we looked at how Yetibot propagates data from an API across pipes, and this is how it does it, at least in the command response. You return a map with result/value, and that's the human-friendly representation that we want to see output in Slack. And then we also give it result/data, which propagates that data across the pipe for commands that want to utilize it. So it's always there, but it's not always necessarily used. So this should just pull out the normalized city name and return it. Okay, it's complaining unresolved CS. So I had a typo there. CS doesn't exist. Instead, we're giving it result. Back over to Slack, and we can see we should get the city name back, and there it is. Okay, so we're on track, but now what we need to do is come up with a human-friendly representation of this massive API response. So looking back at the current functionality, weather command, that uses a function called format current. If we take a look at that, we can see it's just mapping the data structure over a bunch of things like format location title, description, and so on. So we're going to create a new formatting function, but we also want to utilize any existing functions. So format location title, if we look at that, it has some destructuring logic to pull out city name, state code, and country code. So we can use that with our result because the API response happens to have those exact same keys. So call this location, pass the results of that, and now we'll switch out city name for location, and we should get a full human-friendly representation. Instead of just San Jose, it should be San Jose, California, US. Okay, and then next we want to add the actual forecast results to it. And to do that, we basically want a formatting function that takes a forecast item that looks like this and returns a string like min, let's see, date min to max. So that's our goal. So we'll use destructuring in the arguments to the function once again to pull out the things we're interested in. So min temp, max temp, and valid date. And providing a docstring like this allows us to look up the help from a function, like if we were using this somewhere else. Evaluate the function, and then I can see down here the metadata that we associated on it, the docstring and the arguments. So it's really helpful for like dev time lookups. All right, so given min temp, max temp, and valid date, we want to format a string. So how do you do that? We use the format function. If I grab the help on that, it uses Java Lang string format, and a lot of you are probably familiar with that. So it looks like this. These are all placeholders for values, and then we pass those in. So valid date, min temp, and max temp. And it should return a string in this desired format. So let's try that out. Evaluate that function. And then what we need to do is pull out the data from this map. We saw data was one of the keys, and that maps to this collection of all the forecast items. So we can pull out data right here when we destructure the result. And then we need a way to return the location and the other items in a like a multi-line Yetibot response. So to do that, we can pass a collection as the response, like a vector of strings, and Yetibot will output those each on a new line. So instead of just saying location, we can append two collections using into. So a quick example of what into looks like. all it's doing is concatenating two lists together. So we put our location string into a list, and then we're going to concatenate the list of forecast items into it. So a lot of you are probably familiar with map. It exists in JavaScript now, but it allows us to basically pass each item from a collection into a function, transforming it, and then using that as the result. So format forecast item should be what we want. And we're passing data to it, which again corresponds to this map of forecast items. Delete that. Reevaluate the entire namespace, and then we can go test it out. All right, looks good. So that was our location. That was in the first list, and then into concatenated all the formatted forecast items. So one problem is our temperatures are just these kind of unformatted strings, and they're also in Celsius. So we need to localize those. And we have a function for that because, again, if we went back to weather, the existing command, we can see we get this more friendly representation of the temperature converted to Fahrenheit. So let's look at how it does that. So the way it works is when we get back the temperature from a country, we inspect the country code and convert it to Fahrenheit or leave it as Celsius, depending on whether what the convention is. So apparently in Liberia, Myanmar, and only the United States, we have Fahrenheit, and then everyone else uses Celsius. So we can ask for the alltemps and temp by passing it the temp and just giving it a country code, and we should get the correct thing back. So let's go back to our format, forecast item, and that means we'll also need the country code. As a parameter, and then the second parameter will be that forecast item. So if we go back to where we're calling it, back here, let's grab the country code and pass that as the first parameter. So one thing we need to do here is partially apply forecast item, and what that means is we're creating a new function where the first argument is already basically bound. Code. And then map will provide the second item, second argument to that function. And now using that country code, we can format these. So alltemps and temp, grab the docstring on that. We see it's temp, cc. Do the same for max temp. And then reevaluate that. And we can test it out. So now we see that we're getting this kind of strange vector representation of our temperature. So let's go look at alltemps temp again. And we can see it's calling alltemps value, but that's returning a vector of items instead of a string representation. Oh, actually, we have a format temp here. Okay, so then, so that's returning a vector of the converted value and the symbol, like C or F. And then we can use those by applying it to format temp. So what apply does is it takes a collection of values and applies it to a function as if those were the arguments you passed to the function. So if we reload that, try it again. Now we have our nice human-friendly representation. And again, all the data behind that command is available, so we can inspect it with data show. And we can see everything's still available. We could render a custom representation of that if we wanted to, using templating. Like render country code. So that's it. That was how you work on Yetibot, how to add sub-expressions, and kind of a whirlwind tour of Clojure itself and the integrated or interactive development workflow. Any questions on that?
The indentation is like part of the syntax, or is it arbitrary?
It's arbitrary, but it's pretty,
Sort of concept of indentation, obviously, just writing it so it's easier to read.
right, yeah. So Clojure doesn't care about white space, but it's pretty well accepted that this is how you indent.
So the Yetibot itself called the API, right?
Right.
How do you deal with things like application token, the developer token? How is that set up?
Yeah, so currently there's just configuration for API keys that are not user specific. So right now, basically there's nothing user specific. I have ideas on how we could maybe do like support an OAuth flow for an individual, like who wants to interact with Altis or something that's specific to a user account. We could use a web-based OAuth flow, and then Yetibot could store that token internally, but that's future.
So adding a new API integration. So I think I saw something on the top. You have some reports kind of things. Is that where you actually add a new service integration?
Sorry, where was that?
Yeah, so I think the require is where you have some of the API integrations that work with this. Like, how are you making the call to the actual API, weather API?
Mm-hmm.
Is that one of these requires?
Yeah, we're just using an HTTP client. This function getJSON kind of encapsulates the call, but if you look at this, it's just a way to hit a URL with get and some options that includes our API key, the units, and the path. So it's all right here, just using a simple HTTP client. Other more complicated functions like the GitHub integration, there's actually a Clojure GitHub client library. So instead of just making raw HTTP requests, I can use the library, passing it arguments, and it kind of forms those requests for me. So it's just convenience based. Namespaces map to all of our commands. So this is the structure of a namespace, yetibot.commands.feature basically. So if I browse this directory, you can see there's a ton of different namespaces. Here's our eBay feature. You can see the eBay feature is tiny. There is an API namespace that encapsulates the find item functionality, but yeah, a lot of commands end up being really short because the language is super expressive and really easy to, like I showed, kind of pull data apart and format it and stuff like that. So I can grab the first 3 results of iPhone on eBay. Any other questions?
So the way to compile Clojure to JavaScript, I think I did something about that.
Yeah. So Clojure script targets JavaScript, basically kind of the same way Clojure targets JVM bytecode. There's a whole kind of subset of tooling and libraries that the community is building up. Like there's React wrappers, several of them actually in Clojure, and they're doing some really interesting stuff for front end, kind of like alternatives to Redux, and almost even more kind of mind blowing and complex. But yeah, so that's a kind of a smaller subset of the Clojure community doing some really cool stuff.
What's your impression of the community around this? Is it really vibrant, or is it dying out slowly, or what's the status?
I think it's been slowly growing. I think its biggest hurdle is just the syntax. It's just so different than any other language. But the community is really strong. There's a ton of conferences, tons of great libraries. Libraries exist for almost anything you need.
Also around the compared to JavaScript?
Yeah, it's a smaller subset, I would say, and there's a little bit more pain in terms of like, instead of just a quick refresh cycle during development, there's maybe a couple extra seconds of compile time before the JavaScript shows up.
I noticed that immediately when I tried to some examples in the web.
Yeah, I think, but on the plus side, like some of the stuff they're doing is so interesting and kind of based in academia that it almost makes up for it. Cool. So if you join the Slack channel, there are resources. There's links to the slides in the About section of the channel that you can find. And the slides have some resources for getting started. So if you're wondering why to learn Lisp, this Paul Graham post is a really good explanation. Lisp is worth learning for the profound enlightenment experience you have when you finally get it. And then beyond that, there's a bunch of really great resources online. I don't want to go through trying to show you how to set up your environment if you want to hack on it. This is a really good intro. It has guides for all the main editors, so whether you use Vim or Emacs or IntelliJ or whatever, it has a guide to do that. Number 3 is a cheat sheet, so kind of like we did in the beginning where we flew through a bunch of features, this is a really concise document. And then there's some other great community-powered kind of an API reference, where you can see usage examples of like every command you can think of, or every function you can think of, like reduce and fold and all that kind of stuff. Awesome Clojure is just a README file on GitHub that lists tons of different resources, and you'll find all this stuff in there as well. And then yetibot.com, Yetibot's own docs. So with that, you can ask me questions. You can hack on Clojure, hack on Yetibot. The slides have some links to Yetibot's issue tracker. The good first issue labels are usually pretty easy, pretty good place to start if you want to hack on it, and then quite fun are just ideas that are really fun. And there's other ways you can contribute just by playing with Yetibot. You can document any pain points. You can come up with feature requests. If you have some internal system at eBay that you want to expose via Slack, let me know if you have ideas. Be happy to build things if people want to use them.